Okay, so we're going to continue on with sine law, and we're going to look at some more examples. So I'm going to draw another one up, and I'd like you to pause the video, give it a try, and then unpause the video and see how you did. So I'm just going to draw a really quick triangle here. Here we go, a really quick triangle. Let's say that we knew that this angle here was, I don't know, 70. Oh, what's going on? Stop that. Unclick there. Oh, why are you doing that? Stop. All right, so let's get rid of those things. Okay, so we know that this angle here is 75 degrees. And let's say that this angle was, I don't know, a little bit less than that, so 61 degrees. And I'm going to tell you that this side right here this looks to be 15 meters. And what I'd like to do is I'd like you to determine the side length there. So go ahead, give it a whirl, pause the video, and try it. Okay, welcome back. So what we're going to do is we're going to label off each of the vertices. So it doesn't really matter where you put the labels, A, B, C, but as a reminder, of course, the vertices have to be labeled with uppercase. And then we're going to label off the opposite side with the lowercase letter that matches. So this is A, so over here is going to be lowercase a, lowercase b, and lowercase c. Again, the variables don't really matter so long as the corners are uppercase and the vertices, the vertices are uppercase and the sides themselves are lowercase. So I'm looking for a side length. So I'm going to go with the variant of the sine law where the side lengths are on top. So I'm going to do A over the sine of A equals B over the sine of B equals C over the sine of C. I'm going to fill everything in. So A, lowercase a, is x. So it's going to be x over, and then uppercase A is 75. So it's going to be the sine of 75 degrees equals B. Well, I've got B is 15 here over sine B, which is going to be, of course, the sine of 61. And then C, nothing going on with C, so I'm going to leave that. Uppercase C, nothing going on there either. So sine of uppercase C. So recall what we're looking for. So we have to have, first off, we have to have a complete ratio, which we've got, right? If we look over here, the very center ratio, this is a complete ratio. So yay, we've got a complete. And then the second thing that we're going to need to have is we're going to need to have a half full ratio, right? So half full. And here's what we've got. There's a half full ratio right there. So we're going to have to use those two. Those two are going to form what it is that I'm going to have to do from here. So I'm going to say, all right, I'm going to use those two ratios because they are the ones that are complete and half complete. So I'm going to rewrite them. You don't necessarily have to rewrite them, but I'm going to rewrite them just to give me some more room to work with. So sine of 61. Now, I want to solve for x. I know that when I get down to the bottom, I want to have x all by itself, x equals, and then some number going on. Right now, x is being divided by the sine of 75. So the opposite of that is, of course, multiplication by the sine of 75 degrees. And if I have to do it on the left, I have to do it on the right as well. So I'm going to multiply by the sine of 75 degrees. Those ones are going to go away. So this is you don't really need to write this step. I'm just going to write it for clarity. So we have 15 over the sine of 61 times the sine of 75. So I'm going to grab my calculator and I'm going to type that in exactly as it appears. I turned my calculator off, so I'm going to have to make sure that I go back in and get it back into degrees. So there it is, degrees. And I'm going to type it in. So we're going to have 15. 15, let's just make sure. I'm not sure. Okay, good. So I have 15 divided by the sine of 61, and then I'm going to multiply by the sine of 75. So I do that, and we're going to get 16.57. So I'm going to come back down here and say excellent. So I've got 16.57, and the units here are meters. So I found and hopefully you did as well, the unknown side length. Okay, so let's look and see how we could maybe take that a little bit further, but still going for side lengths. So that's not really a straight side, but that's okay. There's a straight side, and there's a straight side. So we're good. So imagine that we had, I don't know, that looks to be 62 degrees, and that looks to be 55 degrees. And here we're gonna make it a little bit more challenging. I'm gonna say this side over here, that's 8 meters. And now I'm gonna say I want X and Y, okay? So it sets up a little bit differently because I've got two variables going on, but we're gonna still say, all right, I am looking for side lengths. So I'm gonna label off my vertices, uppercase. Maybe this time I'm gonna label them D, E, and F. Again, it doesn't really matter so long as you label the vertices uppercase. Opposite over here is going to be little d. Opposite over here is little f. Over here is little e. So now I'm still looking for side lengths. So I want my side length on top. So I'm going to write d over sine d equals e over sine e equals f over the sine of, that should be uppercase, of course, uppercase f. There we go. So we're going to fill in all of our values. Lowercase d, well, that's y. And then sine of uppercase d, that's 62. So the sine of 62 equals uppercase or lowercase e. Now that's going to be x over, right now it's just e. So I'm going to leave it as the sine of e equals f. Well, f is 8 over the sine of f. Well, that's 55. So the sine of 55. So what do we have to have? Remind, of course, we have to have a complete ratio. Well, there we go. We've got a complete ratio. And we have to have a half complete ratio. Well, we populated something here, but neither one of them have a value. So that doesn't count as our half complete. But we do have a half complete here because we have a number here and a variable here. So there's my half complete. So I'm going to use these two, and I can just kind of ignore that one. So I'm going to rewrite them so that they're side by side to make it a little more obvious. So we're going to have y over the sine of 62 equals 8 over the sine of 55. Okay, there we go. Similar to before, being divided by the sine of 62. So I'm going to multiply by the sine of 62. So I'm going to multiply by the sine of 62. Those guys are going to go away, and we're going to have y equals this. So I'm not going to rewrite it this time. I'm just going to go ahead and I'm going to type that into my calculator and get the answer. So we're going to have 8 divided by the sine of 55 times the sine of 62. And I do that, and I'm going to get 8.62. So I know that y is, in fact, 8.62, and that would be meters as well. Well, that's good. So I can go back here and say, all right, now I know that y is, I'm going to change colors just so I can see that I did it afterwards, 8.62. Okay, lovely. But I really wanted x. Here's the problem. I have a totally incomplete ratio. Nothing, right? So no values. But we're not going to forget our grade, 7 math. We know that the angles inside of a triangle have to add up to 180 degrees. So that means that angle E plus 62 plus 55 have to add up to 180. So we can solve for what angle E is. It's going to be 180 minus those values. I'm going to grab my calculator. I should do this without a calculator. We're going to do the calculator anyways. So 180 minus 62 minus 55, and we're going to get 63 degrees. So E is in fact 63 degrees. So I can go back here and I can say, excellent, this is actually the sine of 63 degrees. So now if we think about the ratios, I know what y value is, right? I know that this is actually 8.62. So we're up to this one being complete, and this one is complete, right? And now this one is half complete, so we're good to go. So in theory, children, what we could do, I don't even know what color that is. That looks kind of reddish to me. We could use these two ratios to work, right? Because we now have a complete and a half complete. The risk if I use these two ratios is that if I made a mistake solving for y, even if I did everything else right to solve for x, I'm going to get the wrong answer because I started with the wrong y value. So in that case, what we're going to do instead, obviously, is we are going to use these two ratios. Okay, we should always try to use the ratio. This ratio were original. These were given values. So because those are given, I know that there's not a mistake there. So I'm going to use these two ratios now. So I'm going to rewrite them just to get them clean again. So we're going to have x over the sine of 63 is equal to 8 over the sine of 55. And I'm going to solve. I'm going to multiply both sides by the sine of 63. Didn't give myself much room there. So sine 63. And I'm going to multiply over here, obviously, by sine of 63. Those guys are going to go away. And what I'm going to have now is I'm going to rewrite it because it's pretty messy. X equals 8 divided by the sine of 55. And that's going to be multiplied by the sine of 63. So I can drop that into my calculator. Grab my calculator. Here we go. So we're going to have 8 divided by the sine of 55. And I'm going to multiply by the sine of 63. Okay. And we're going to get 8.70. So we just found x equals, that's not a nice x. And I've already forgotten the number. X equals 8.70. Okay, so x equals 8.70 meters. So we were able to find the other two sides. Okay, so what I'm going to do now is I'm going to write up a bunch of homework questions I'd like you to try for right now. And then next week, when we pick back up, we will look at solving using the sine law to solve for unknown angles. And then we'll get right into cosine law, and then we'll start looking at some applications of basic trig. Okay, so I'm going to kind of sign out now, and I'm going to post this image onto Google Classroom as well. And at the bottom of this image will be all of the homework questions. Okay, great. Thanks, guys. Bye.